A2x plus B2y is equal to D2 is the second equation. These two equations can be expressed in matrix form. This is the matrix formed by the coefficients of x and y. The coefficient of x in the first equation is a1, coefficient of y in the second equation is b1. Coefficient of x in the second, this is the coefficient of x in the first equation is a1, coefficient of y in the first equation is b1, coefficient of x in the second equation is a2, coefficient of y in the second equation is b2. These two are the unknown quantities. X and y are the unknown quantities. D1 and D2 are the constants in equation 1 and 2. Now let capital A, matrix A is equal to the coefficient formed by the coefficients of x and y, and capital X is the unknown quantities x and y. Capital D, that is matrix D, is the constants in the two equations. These matrices can be expressed in this form, that is matrix A into matrix X is equal to matrix D, call that equation 1. Multiply left side of this equation by A inverse, so that A inverse into A into X is equal to A inverse into A. These are all matrices. A inverse is also a matrix. A inverse is matrix, A is also matrix, and X is also matrix. Now, if you multiply one matrix A with its A inverse, we will get the identity matrix I. So, therefore, I into X is equal to A inverse into D. If you multiply identity matrix with the X matrix, we will get matrix X only. Therefore, X is equal to A inverse into D. So, by using this equation, we can solve the unknown quantities X and Y. This equation can be applied for three equations with three unknowns also. Solve the equations using matrix method. 5x plus 2y is equal to 4, 7x plus 3y is equal to 5. Now, consider matrix A is equal to the coefficients of x and y, that is 5, 2, 7, 3. Matrix X is equal to the variables, not variables, that is unknown quantities x and y, and matrix D is equal to constants 4 and 5. Now we have to solve these two equations by matrix method. So matrix X is equal to A inverse into D we have, because from these three, matrix A into matrix X is equal to D, that implies X is equal to A inverse D. Now we have to find inverse matrix of this A. We have matrix A is equal to 5, 2, 7, 3. To find inverse matrix of this one, first we have to find the adjoint of A. Adjoint of matrix A is equal to adjoint of 2 cross 2 matrix can be obtained by interchanging the principal diagonal elements 3 and 5. 5 and 3 becomes 3 and 5. Changing the sign of the secondary diagonal elements, that we know. Therefore, adj is equal to 5 minus 2. These two are the secondary diagonal elements and these two are the principal diagonal elements. I interchanged the principal diagonal elements and changed the sign of the secondary diagonal elements. Now, determinant A is equal to 5, 2, 7, 3. That is 5 3s are 15, product of the principal diagonal elements minus the product of the secondary diagonal elements. 2 7s are 14. So 15 minus 14 is equal to 1. Now A inverse is equal to 1 by determinant A into adj. We know this. Therefore, 1 by 1 into adjoint A is 3 minus 2 minus 7, 5. Now, therefore, matrix X is equal to A inverse into D we have. What is the value of A inverse? A inverse is equal to 1 by 1 is nothing but 1. Therefore, 3 minus 2 minus 7, 5 into matrix D 4, 5. If I simplify this to 3 4 the 12 plus 5 into minus 2 10 minus 10. 5 into minus 2 is minus 10. Next 7 4 the 28 minus 28 because 4 into minus 7 plus 25. That is x, matrix x is nothing but x and y from this is equal to 12 minus 10 is 2 minus 28 plus 25 minus 3. These two matrices are equal, therefore the corresponding element must be equal. So this implies x is equal to 2 and y is equal to minus 3.